Time series analysis, at the end of this topic, you will be able to define the components of a time series. So there are 4 components. So you have to be able to define it. Number 2, you should explain time series models. So there are 2 models. You have to know the benefits of those models, how you can use those models. Number 3, you should be able to determine a linear trend equation. So that means you have to develop an equation, linear equation. So already you have completed regression methodology in statistics. So using that knowledge, so here you are going to apply the knowledge to determine a linear trend equation. Number 4, using that equation, you should be able to forecast. The time series is about forecasting. So you should be able to forecast for future time periods. And also you should be able to develop seasonally adjusted forecast. So, you know, forecasting involves so many things. So one is seasonal patterns. So you have to be able to incorporate that seasonal patterns into your forecast. Then next, you should know to compute moving average. So I will teach what is moving average. So you should be able to compute it. Then you have to be able to determine and interpret the set of seasonal indexes. So seasonal indexes, you have to be able to calculate and interpret it. You know, business statistics is not about calculation. It is about calculation plus interpretation. As statisticians, you should know how to interpret the data. So that is number 6. Then number 7, deseasonalization. So that I will explain. So these are the 7 objectives you should accomplish after finishing this topic. Right. So I need 3 days. That means 6 hours to complete this topic. So step by step, we can finish this. So now we are going to the introduction part. So the first question, what is time series? So you should know what is meant by time series. So that definition says any variable that is measured over time. Any variable that is measured over time. So you know what a variable is, right? You should have studied about variables. Variable can take any values. So for example, sales. Sales is a variable, right? So it can take any numbers, 10,000, 20,000, 100, 500. So sales is a variable. If that variable is measured over time, right? For example, sales in January, sales in March, sales in April, sales in December. So I am giving you the time, right? March, January, April, December. So these are the time measured over time and in sequential order. So that is important, this sequential order. There must be an order. January, February, March, April, likewise. So there must be a variable. That variable must be measured over time and it should be in sequential order. There are 3 conditions. Then you can tell it is a time series, right? So sales is not time series, but monthly sales is a time series data. Annual sales is a time series data, right? So that is the difference. So first you have to know what a time series. is, right? So that is the first explanation. Then the second question, why we want to analyze time series. So why we want to analyze? It is for detect the patterns. So why we analyzing time series? To detect the patterns. So there is a graph. So here you can see there are so many dots, right? There are so many time series points. So by looking this point, can anyone tell me what is the pattern? Whether it is increasing or decreasing or constant, no movement.
Decreasing, sir.
Yeah, very good. I got a chat message also decreasing. You can unmute your mic and talk, or you can put in chat box, but I expect you to talk. Decreasing, right? So here you can see the line is going down. So now you know this time series reveal a decreasing trend, right? Therefore, I have noted here the time series exhibit a downward trend pattern. So downward. So therefore, because of that, we are analyzing the time series. Number two. Number three, the point number three, forecasting future. This pattern helps us to forecast. Forecast what? Forecast future values. So now now a sales manager, assume this is sales. Sales manager, now he knows what will happen for the next month or for the next year, because now he knows the pattern. So what will happen? So he can forecast the next point where it will be, the place where they can forecast. So that is called forecasting, right? So this is the introduction of time series. So what is time series? Any variable that is measured over time in sequential order. So why we are doing that? To detect the patterns. What is the purpose of detecting patterns? We can forecast for future, right? So this is the basics. So with these basics, I am moving to the next part. The time series components. So this is your first learning objective. You should know what are the time series components. So basically, there are four components: trend, seasonal, cyclical, random. If you take a time series data, for example, annual sales, right? Number of customers visiting ATM machines, number of production happening in a textile factory, so whatever. These time series components may have this time series may have these components. So there are four components. So you should know what are these components, right? What are the differences? You should know clearly. So now we will study one by one. The first component is trend. Trend is the first component. So definition says a trend is the basic tendency of a steady movement. So the keyword is basic tendency of a steady movement, right? Steady movement in a set of observations to moving an upward or downward or a constant direction over a fairly long period. So here you have two key points: steady movement, long period of time. So simply said, trend is the long-term movement, long-term steady movement, that is trend. So here you can see there's a sales time series, there are 1, 2, 3, 4, 5, 6 points. 6 time points are there. Assume they are annual sales in 6 years. Now tell me, what is the trend here? Upward trend or downward trend or constant direction? Anyone? Can you observe an upward trend or downward trend or constant direction?
Both upward and downward trend.
Upward and downward. Where is the downward here? That means, all right, okay. May I know your good name? Who answered? The name, please.
Saranya.
Right, Saranya. So you are telling upward and downward because you are thinking this is upward and you are thinking this is downward, right? So that because of that you are telling upward and downward. But when you are analyzing trend, you have to see the long-term pattern, right? Yeah, you have to assume a line, a long-term line. So if you draw a line here, connecting all these points, a common line, the line will be like this, right? A common line tries to connect all the points. A straight line you can draw like this. So by looking this, you can tell this is upward trend, right? In long term, it is going up. In short term, there may be different up and downs. Maybe monthly, this may be February, this may be March, this may be April. So within months, there are up and downs. But if you take the year, that is increasing, right? Starting point and ending point, you can see definitely there's an increasing trend. Have you understood, Saranya?
Yes, sir.
Right, good. Then I got some answers in the chat box. Yeah, upward trend. Okay, so there are 200 students. So I need active participation, right? Okay, so now you know what a trend is. Now we are moving to the second component, that is seasonal component. It's called seasonal variations. So definition says, seasonal variations are the regular periodic changes which take place within a period of less than a year. So what is the time frame? Within 1 year. Within 1 year, there may be some periodic changes, up and downs. So that is called seasonal variation. Trend is the long term. More than 1 year, you have to see the trend. But seasonal variations are short-term components. For example, if you see this graph, you can see Q1 and Q3. Q1 and Q3. There are ups. There are some downs in Q2 and Q4. So within 1 year, there are up and downs. That's why they are telling upward or downward swings. Then regular patterns. Observe within 1 year. Within 1 year, you can observe this up and down. So basically, you can see the sales of what you call umbrella and raincoats will go up in rainy season. Maybe October, November, December, January, those months, there may be more sales. for raincoat and umbrellas. If you take sales of textile, right? Because of festival seasons, maybe April or November or December, those maybe January, because of festivals, again sales will go up for textiles, dresses especially. And if you see the tourism industry, the sales of tourism, right? Sales, tourism related sales may go up in summer season of foreign countries, most probably from April to August. So based on in those particular months, sales will go up. That is called seasonal component. No, I hope that you have understood clearly about these two components. So now we are moving to the third component. That is right here. This I would like to show you a small graph. So in this graph, I have shown two components, right? So you can see the trend component, that is the line, orange color line shows you the trend component. Because I told trend is long term, so you can see 2013, 2003, 4, 5, 3-year data. So 3-year data, the trend is going upward. Trend is going up from this point to this point. Trend is upward. In the same chart, I have shown you the seasonal variations. So you can see the seasonal variations in each year. 2003, this is the seasonal variation. 2004, this is the 2004 sales variation. 2005 again. So within those years, there are up and downs. You can see up and downs. Within 1 year, there are variations. For each year, there are variations. So those are the seasonal variations. For each year, there are variations. So those are the seasonal variations. Right. So now I am moving to third component, cyclical component. Cyclical variations are the periodic movements. Again, they are periodic movements in the time series around the trend line. Right? Around the trend line. Here, they are also periodic movements, periodic up and downs, but around the trend line. Trend line means, trend is a long term, very long term. So in the long term also, there may be up and downs. A very good example for that is the economy of a country. If you take an economy of country, most probably there will be up and downs for a long term. For some years, there may be a boom, right? Very good GDP, very high growth, right? GDP growth, good level of income. For some years, it may come down. In particular year, it may go to very bad level, very steep. Then again, it may go up. So there may be up and downs, but more than 1 year. The time period is more than 1 year. Therefore, the point says upward and downward swings may vary in length. Is very important. Time period 2 to 10 years. Up and downs in 2 to 10 years. Right? So I will explain that by another chart. So here you can see from 1988. From 1988 to 2005, a very long period graph. First, you tell me what is the trend here, upward or downward, or constant? Yeah, very good. Upward trend. Which line tells you this is upward trend?
The yellow color line.
Yeah, very good. There's a yellow color line. So this line, right? Yellow color line tells you upward trend. But if you see the data pattern, there are up and downs. Those up and downs are periodic changes. So it's an economical effect. So here you can see the same pattern is repeating. This same pattern you can see here also. Right? Same pattern comes again and again. That is called, but more than 1 year. Time period is more than 1 year, but same pattern is coming again and again. Same up and downs are coming again and again. So these are called cyclical variations. So here you can see first prosperity, a very good point in for the country. Then it goes down. Then again, say recovery period, so goes up. Then again goes down, recession. So prosperity, recovery, recession, depression. So these points are coming again and again. So that is why these are cyclical components. Then what is cycle, right? You should know what is a cycle. One cycle is the difference between the same 2 points. It's called one cycle. So here you can see this is a point of prosperity and this is another point of prosperity. So this time period is one cycle. From one prosperity to another prosperity is considered as one cycle, right? So the difference between the same type of time periods. So now we have completed 3 components. Number 1, trend, long-term movement. Number 2, seasonal component, short-term up and downs. Number 3, cyclical component, long-term up and down. Number 4, the next component is random component or irregular component. Sometimes they will tell residual component. So these are some names assigned to this particular component. So these variations occur on account of random external events. You cannot forecast this. You don't know when it will happen. Unexpectedly, it will occur. Can anyone tell some examples for unexpected occurrences around the world?
Natural disasters.
Nature and disasters. Yeah. Example for nature disasters?
Tsunami.
Good. Tsunami. Very recently.
Raining.
What is that?
Raining.
I could not understand. Okay. Anyhow, thank you for that. COVID-19. COVID is a very good example where you have experience. Right. Maybe you may not know the impact of tsunami, but you have the experience of COVID. So these are random accidents, right? Random events. Maybe some accidents in your factories, accidents in your production factories, or natural disasters, Oh, the economic crisis now we are having, those are also random, right? So it's of short duration. That is another character. Duration is very short, right? Of course, COVID is exception. COVID was 2 to 3 years. Still, there are some problems, but we hope it will not repeat again. Anyhow, they will try to stop it. We hope. Non-repeating, it will not come again and again. In a time series, it will occur 1 or 2 times. So that floods, right? Hurricanes, those things. So these are the random events or irregular components. So these are the four important components of time series, right? So now you have completed the first learning objective. They have to be with the class. They cannot go there, here and there. So I will do some polls like this then and there to check whether how many students are actively participating. So far, 160 students have participated. So very good. Okay, so the question was, what are the short-term components, right? There are 4 components, but some are short-term, some are long-term. So majority of you have answered seasonal component. So very good. So that is one answer. Second majority goes to irregular component. That is also short term. But still, some 28 students you have answered trend component. And 17 students you have answered cyclical component. So trend, whether it is short term or long term. So I hope now you can see the percentage. So my question is, trend, whether short term or long term?
Long term.
Trend is long term, right? More than 1 year. Steady movement for a long term, that is the definition. So it will not come under short term. Then cyclical, that is also periodical movements for more than 2 years, 2 to 10 years. That is also long term. So trend and cyclical components are long-term components. Seasonal and irregular components are short-term components, right? So I just checked your understanding. So thank you very much for the participation. So now we can move to the next part. The models of time series. The models of time series. So there are 2 models. So these models tells you the relationship between these 4 components. You know there are 4 components. Between these 4 components, there are some relationships. So those relationships are shown, right, are modeled by these time series model. So there are 2 types of models. So number 1, the additive model. So this model says you have to add the components. So you can see here they are adding all the components. T, time, so trend, seasonal, cyclical, and irregular, they are adding to get the time series value. So time series value is denoted by Y. Y is the time series value, maybe the forecasted value, you can tell. So that value includes 4 components you are adding. Another model is there, which is called multiplicative model. So this model, they are multiplying all the components. You can see the multiplication sign. So they are multiplying all the components to get the time series forecasted value. So these are the two differences. But the practitioners, statisticians, they recommend using the second model, right? There are some benefits of multiplicative models compared to the additive model. So I am not going to talk about that. So if you want to learn about that, you can Google it, or you can search, or you can read the books, which is the better model. That is for your reference. So now you have to know there are two models that shows the relationship between these components. So with that information, now I'm going to give you a small work. So all of you, you must have rough sheets or papers or notebooks with you in my subject. So when I am giving exercises, you also have to practice that, and you have to tell me the answer. So that practice is very important because we are not meeting face to face. So you are at home at your own convenience. So therefore, at least try to practice some exercises during the class. That for sure it will help you in examinations also. So my first exercise will be on additive model. So here I have given 4 values for 4 components. So you have the model here. You have the model here. So using this model, you have to tell me the answer. What is the forecasted time series value? The trend is 50,000, seasonal variation 10,000, cyclical variation minus 2,500, and irregular component minus 1,000. So what is the answer? You can put the answer in chat box. I am getting 2 different answers, 63,500 and 56,500. So therefore we have to check what is the correct answer. So here we will quickly check that. So additive model says that YT is equal to trend, plus seasonal plus cyclical plus irregular component. So I can put I for that. Right. So here I have given you the values. Trend component is 50,000. Seasonal component also 10,000. So I am adding. But the cyclical component is minus 2,500. So be careful about the minus value. That is minus 2,500. And irregular component also minus 1,000. So the minus values you have to be more careful. So minus means there are some uh, downward pattern, right? Cyclical minus means maybe the economy or the company is going down in the sales or whatever output. Irregular minus means there may be some natural disasters or natural problems. Therefore, minus. Then if you get the total, then 6,000, 56,500. That is your final answer. So be careful about the minus values. So I hope now you have understood this. And COM 113, you have answered like this. Very good. You are putting the notation and you are putting like this, right? 5,500 T. So COM 113, this T don't put, right? This T don't put T, only 56,500. YT is equal to, sorry, my battery is weak, 56,500. That is enough. Don't put T. Understood? COM 113. Right, okay. So that is about the additive model. So now I am moving to another exercise for multiplicative model. So here again, I am giving you the values for time series components using the multiplicative model. Now, okay, very good. So all of you are giving the correct answers. So, right, very good. So anyhow, I will do that for those who did not understand. So simple. Here multiplicative model means what you have to do is just multiply all the components, trend into seasonal into cyclical into irregular. Just multiply. So I think 1 million into seasonal variation (1.7) into cyclical 0.91 into 0.87. So the answer will be 1,345,890. So your answers are correct. Right. So thank you. So I have a question here for you that seasonal variation, the component value was 1.7. So what do you mean by this? Anyone? Seasonal variation 1.7. What is the interpretation of this? Any student? If you know, you can tell me the answer. Assume that this model has only trend and seasonal variation. No other two variations, right? Only two components. Yeah, MS85, very good. You have told upward trend. How did you decide MS85? This is upward trend. How did you decide it? Positive value. Because it is positive, you decided upward trend. Then MS85, I have another question. The cyclical value was 0.91. That is also upward trend. Cyclical value was 0.91. Is that upward trend? Is that going up? No. Then how did you decide this is not going up? Very good. Below 1. Right. Better you can talk to me, right? Rather than typing. Anyhow, you found the answer below 1. So here what you have to check is whether one more answer I got. Very good, MS 147. 147 gives the correct answer. Check whether seasonal variation is above 1 or whether it is below 1. Whether it is above 1 or below 1. That is the decision point. Right. So here I will come back. Here 1.7. 1.7 means above 1. So that is it's going up, right? Going up. That's 1.7. So for example, if the trend is 1000, if the normal trend is 1000, tree is not working. But if the trend is 1000, if the seasonal effect is 1.7, the answer will be definitely 1700. So you can see trend is 1000, but the expected value is 1700. That means it's going up. So what is the interpretation of 1.7 means in the particular month or particular time period, right? In the particular time period, the sales will increase by 70 percentage. Sales will increase by 70 percentage. So increase, that is the keyword. So why it is increasing? Because the seasonal component value is more than 1. So it is increasing. By how much? 70 percentage. How did you calculate that 70 percentage? Because you can simply see this 1.7, no, 1.7 means you can deduct 1. 1 means the general trend is 1. So if you deduct 1, the answer is 0.7. So 0.7 into 100, you are converting that to percentage, that is 70 percentage. So 1.7 means 70 percentage increase in the particular time period. So that is the interpretation of this seasonal component. So now I hope you have understood. So now tell me the cyclical component was 0.91. Can anyone now tell the interpretation for cyclical component? You have to tell two things, whether it is increasing or decreasing and by how much, what percentage. Yes, correct answer MS 85. Anyone? MS 107 correct, 147 correct, but 37 your answer is wrong. 134 also wrong. MS 13 correct. Same technique. Same technique, just deduct 1. 0.91, just deduct 1. If you deduct 1, the answer is minus 0.09. That is the answer. So if you convert that to percentage, minus 9 percentage. So what is this minus? Minus says decrease. So decrease by 9 percentage. Just deduct 1 from the value and convert it to percentage by multiplying by 100. Then you can get the answer. Increase or decrease, and then by how much? Have you understood now 134 ms and ms 37? Have you understood?
Yes, sir.
Right, okay. So with those understanding, now we are moving to the next section. Right, the question part. So for this, you can, rather than typing your answers, if you like, you can type. Otherwise, you can answer quickly through mic. So associate each of the following with the appropriate component of time series. So I will tell an example. You are going to tell the relevant component. So first one, impact of a strike. Right? Maybe nowadays so many strikes are going on. So impact of a strike, whether it is trend or whether it is seasonal or whether it is cyclical or whether it is random or irregular. Right. So very good. I am getting the answers. Yes, it is irregular. Correct answer. It is irregular. You cannot expect it. You cannot forecast it. Unexpected event. From 104, do you have any problem? You raised your hand, so do you have any problem? From 104. Okay, right. Then number 2, an economic cycle of up and down over 5 years. An economic cycle of up and downs over 5 years. So the keyword is 5 years, up and downs. What is the correct component? Here you have 2 keywords, up and down. You know what is up and down? Variations going up and going down, and 5 years, more than 5 years. Mixed answers. Some students say it is trend, some says it is cyclical. Anyone who said cyclical, can you talk to me why it is cyclical?
Because they mentioned there is an economic cycle.
Sir, it up and down. The trend is only up or down, and the cyclical it's up and downs, and it mentioned 5 years over 5 years. The cyclic it's 2 to 10 years, so it's cyclic.
Yeah, very good. Thank you very much for those two. The first students answered it is because the the question itself, they have told economic cycle of up and down. Okay, but that can be the situation, but you have to technically, you have to be able to prove it. The second students explained it very clearly. Up and down, right? Up and down, going up and going down, again going up and going down. That is called a cycle. So trend is not both. Trend means, so if you see the definition of trend, so I can show you. steady movement. So again, I have to highlight that trend is steady movement. Sometimes it may go up, right? Or it may go down, not both, right? Not both. It will have only one pattern, going up or going down. That is trend, right? So therefore, clearly this is not a trend. So this is not trend because here they have mentioned up and down, both going up and going down. That is not trend. And also 5 years. So 5 years, cyclical definition says 2 to 10 years. So here they have told 5 years. So therefore we can assure this is cyclical component. Okay. So now number 3. What is this? Yes, now you are clear. This is trend because long-term increase of 5% per annum. Every year there's an increase of 5%, and they have mentioned long-term. Therefore, it is clearly trend, obvious, right? Then what is the last one? The increase in sales over Christmas. Yes, it is obvious that seasonal component within 1 year in Christmas time, they are observing an increase. So that is because this is within 1 year, this is seasonal component. So you should be able to clearly identify the component. That was the objective of this question. So now we are moving to the next question. Right. So I will not explain. Read this and answer for the question. Take your own time. I will give you 5 minutes so you can understand and you can answer the question. Then I will explain. Here, the actual means the forecasted value, right? Here, the actual means forecasted value, the time series value. Okay, so I got answer from 2 students. MS111, your answer is correct. But 57, it is wrong. So we will check that, right? So first of all, here tell me, question 2 considers how many components? Generally, there are 4 components, but this question considers how many components?
3.
Yes, 3 components. So here they have given This actual means the forecasted value or the time series value. That is not the component. Then here they have given the trend component and they have given the seasonal values. That means seasonal component. So 1, 2, and they have clearly mentioned there is no cyclical element. So cyclical component is not there. And the question is, find the residual component. So they are asking you to calculate the residual component value. So this is the question. So therefore we have 3 components. So now I am going back to the answer. So you know that here we have 3 components. Y is the actual or the time series value is equal to trend, seasonal, and residual. No cyclical component. So here they have given the actual value. So what is the actual value? What is the time series value? So if you see the question, they have mentioned actual, trend, and seasonal values. If you can see actual, trend, and seasonal values are 523, 465, 1.12. So actual 523, trend 465, and seasonal value is 1.12. So what you have to do, just substitute it. So actual is 523. Actual value is 523. The Y value is 523 is equal to, so what is the trend value?
465.
465 is the trend value. What is the seasonal value? 1.12 is the seasonal value. But they have requested you to calculate the residual value. So this is a way of answering, different way of answering questions. Normally they ask Y, but in this question they have asked R, right? So that is the question. So now you can tell me what is the R value. So you know mathematics, basic mathematics. So by doing fraction or multiplication, tell me the R value now. Com 118, double check your answer. So R is equal to So what is the answer? You have to multiply and deduct, right? So that is 523 divided by 465 into 1.12. That is the answer for R. So that is 1.0042. So double check your answers. R is equal to 1.0042. Some of you have got 2.2. I don't know how you got 2.2. So there is a calculation error. Answer must be 1.0042. That is the irregular component value. Those who got 2.2, please double check your calculation. MS46, why you got 2.2? Okay, so check your answers. This is the correct answer, 1.0042. Okay, so now you have accomplished the next learning objective, so that you should be able to explain the time series models. That is also completed, right? So now we are moving to the learning objective 3. Determine a linear trend equation. So, you know, there are 4 components: trend, seasonal, cyclical, irregular. Cyclical and irregular is out of your scope, right? No need to study in detail about cyclical and irregular, right? That is a big study, no need to do in your level. As undergraduates, you have to study in detail about trend and seasonal variations. Those two are very important to your syllabus. So therefore, the first you have to study about trend clearly. What is, you know what is trend, but you should be able to calculate the trend equation and do the forecasting. That is objective number 3. So objective number 3 is, first you have to develop the equation, right? So now right, welcome back to the session. So can you hear my voice clearly?
Yes, sir.
Right. So I told about objective number 3. We have to now determine how to create, how to develop a linear trend equation. Right, so number 4, that means stop the section number 4, trend analysis. The trend component of a time series can be linear or non-linear. So you know, because you studied regression, analysis. So therefore, you know what is linear, what is non-linear, you know, right? So linear means a straight line, right? Non-linear means up and downs, right? That is non-linear. So trend component can be linear or non-linear. It is easy to isolate the trend component, right? It is easy to isolate the trend component using linear regression. If you have a time series data, you know the data will have trend, the data will have seasonal, the data will have cyclical and irregular. There are 4 components. But using the trend analysis, you can isolate the trend component. You can take that separate, right? Take that apart. You can isolate the component. So that means you can find out the trend component using trend analysis. That is what now we are going to do. So for linear trend, we are not going to study about non-linear. Non-linear, we will not study here. We will study only about the linear part. So that linear trend, we can use this model. The same model, the same regression model you studied in previous classes, y cap. Here we call y. Normally you studied y is equal to b0 plus b1, right? So same model we are using here. Y cap. Why we are putting cap? Y cap means estimation of y. Therefore, we put a cap. So y cap is equal to b0 plus b1 t. T means time, right? This t denotes time, the time period. That is the same model of regression. So now anyone, you can tell me, what do you mean by this b0? In regression, you studied those things. So what is b0? What is b0? First of all, have you completed regression analysis? Have you completed? Thank you for the answer. At least one student have answered. Intercept of the regression line. Very good. So if this is the plot and if this is the line, so intercept this point is B0. Very good. Then what is B1? What is B1? Very good. MS73, yes. 32 also. Slope of regression line. Okay, slope. B1 is the slope. Right. So now we are going to calculate. We are going to find out the slope and we are going to find out the intercept. Then we can develop the model. So one example I have given to you. Annual sales for a pharmaceutical company are believed to change linearly over time based on the last 5 years sales records. Measure the trend component. So you are going to measure the trend components. That means you are going to develop the trend equation. So here I have given you only 5-year data for easy learning purpose. But in practical, there will be at least 10 to 20-year data, right? When you increase the number of periods, your forecast will be accurate. Here we are only using 5 years just for example and explanation purpose. In exams, you may have 10 to 15 years. Right, this is the data. So from 2017 to 2021, the sales in millions have been provided. So now we are going to we are going to develop the trend equation. So you know how to calculate this slope and intercept, the same formula you studied in regression analysis. So you may remember these formulas, B1 and B0, B1 for slope and B0 for intercept, the same formula we are going to use. So therefore, I am going to Excel file to explain how to do it. So if you want the data, you can take a screenshot of this. This is the question, so you can take a screenshot. Okay, so now I am going to the Excel file. So here you have to develop a table like this. So you need 5 columns. So you have to work with me in your notebook. Do the work with me, then you can understand how to do it. So the first column year, the second column X. You know, if you want to do regression, we need 2 variables, one dependent variable and one independent variable. So here in this question, what is the dependent variable? Anyone? What is the dependent variable?
Annual sales.
Okay, very good. Annual sales is the dependent variable. Dependent variable is denoted by X or Y.
Y.
Y. So dependent variable is Y. Then what is the independent variable here? MS73 says year. Yes, exactly. Year is the independent variable, but rather than telling it is year, we have to tell time. Time is the independent variable, right? Because we cannot insert 2017, 18, 19 as the independent variables, right? So calculations will be, because you know the difference. So here we are treating another variable called time, right? Another variable called time denoted by T, right? Actually, that is our X. So we have to create a new variable for time. That is our X variable, independent variable. Year is not, it will not be treated as the independent variable. Year is only for the identification purpose. So what is the independent variable? Time is the independent variable. Then, so now you know there are 2 variables. Time is the independent variable. Annual sales is the dependent variable. So keeping that in your mind, now you can develop this table. So you also develop the table in your notebook. So year 2017, 2018, 2019, 2021. Sales, of course, you know, from your screenshot, you can copy the answers. Sales also I have copied. If my copied answers are wrong, tell me. Then what we can put for time here? Any guess? Any guess? So I was discussing about the time value here. So for time series, we put 1 for the very first year. Then we have to increase by 1 units for each year. So I can put 1, 2, 3, 4, 5. So this is our independent variable and this is our dependent variable. So now you know what to do next. You have to calculate the x squared and you have to calculate the x, y values. So for all these values, you also need to calculate the total values. So for example, the first x squared value is 1 squared, right? 1 into 1. So that is 1. Likewise, you have to calculate the x squared values. Then you have to calculate the xy, that is 1 into 7, xy values. So calculate all the xy values. So after calculating, put what is the total of xy in the chat box. What is the total of xy in the chat box? One 63 is coming and 1517 also coming. We'll check. 163 is the answer, right? Total is 163. So the total is very important. We have to get the total of all the columns. Right, so now you know the total values. So now you have to just apply this in the formula. So the formula for B1 is this one. So the formula for the slope. So now you are going to tell me the numbers. I will substitute because you have completed it. This time don't use chat box, talk in mic, because when I'm editing, I cannot check the chat box. So tell me what is sigma xy?
163.
Very good, 163. Give me 1 second. Right, so sigma xy 163. Then what is sigma x?
15.
15. For the first time, I am hearing a male voice. Then what is sigma y?
50.
Yeah, 50. Then sample size n 5. Then what is sigma x squared?
55.
55. Then what is the answer for this part? The sigma x to the squared, right? So sigma x means 5, 15. So 15 squared, and again n is 5. So this is how you have to substitute, and tell me the final answer, one of you. What will be the final answer for B1? 2.6 one student gave, and 1.3 another one gave. I don't know which one is correct. 1.3 is coming, so I will put 1.3. I did not check. I will put 1.3. You double check it, right? Okay, most of you are giving me 1.3. Then it will be correct, I think. So now we know the slope value is 1.3. So now it's time to calculate the intercept value. So you know y bar minus b1 x bar. So y bar, in the sense, you have to calculate the average of y, right? Average of y. So that is total y divided by n. So total y is 50. So 50 divided by n, average of y. Then b1 we have already calculated, 1.3 into, again, the average of x. So total is 15 divided by sample size 5. Right. So this is how you have to calculate B0. So what is the answer for B0? Those who have calculated?
6.1.
6.1. Answer they are giving as 6.1. Yeah, that is, you are giving 6.1. Okay. So before going to the final, I will double check whether your answers are correct. Intercept 6.1 and B1 is 1.3. So your answer is correct. So therefore, now we can now develop our equation. Right now we can put our equation. So what is the equation format? Do you know what is the format? I have shown that to you. So this is the format. Y cap t is equal to B0 plus B1 t. So in that format, now we are going to give the final answer. So what is the final answer? B0 you have calculated as 6.1 plus B1 you have calculated as 1.3. So this is your final answer. Using the calculation, you have developed the trend equation. Y cap t is equal to 6.1 plus 1.3 t. This is your estimated trend line. So the working is simple. You have to develop the table, identify the dependent variable and independent variable. Time is the independent variable. Start from 1. Then calculate x squared and xy, get the total, and apply the numbers in the formula. Find out B1 slope and find out intercept B0, and then develop the final trend equation. This is the step. Right, okay, so we have completed up to this point. So I will upload this PPT in your LMS. What is your task is, so I will inform your rep when is our next class. So after this slide, there are some questions. So forecast the next value. Likewise, there are 2 questions. And again, there is a big exercise, right? Same technique. So attempt this question number 3. You have developed the trend equation using these values. So attempt this question. And when you come to next class, come with the answers. Come with the answers up to question number 5, right? So then we can discuss the answers of all these questions and we can go to the next section. That is what I want to tell you. So today we have completed 3 objectives. The first objective was define the components of time series. So we have studied about the 4 components. Then you know now how to explain time series models and how to do calculations. And also now you have knowledge about developing trend equations. So these 3 objectives we have completed. So with that, I would like to wind up. Okay, before starting the session today, I hope you checked your LMS. So I had uploaded the lecture PowerPoint slides and also I uploaded the video recordings. So those who had interruptions, network interruptions, or those who did not participate in the previous lecture, you can watch the video and do the practice. Okay. Right then, before going into the today's session, I would like to remind you what we studied last class. So last class, we defined the components of time series, 4 components, and you were instructed about the time series models. There are 2 models. So I hope now you can do exercises using those 2 models. And then after that, finally, we learned how to determine a linear trend equation, right? So there are 4 components, but I told you trend and seasonal components are very much important and included in your scope. So therefore, we studied how to derive a trend equation. That was the previous class discussion. Today we are moving to the next part. So we did an exercise last class and I gave you some homework. I hope you practiced that. So those who have found the answers, when I ask the question, you can put the answers, then I can check that. So this exercise, this example we did, and we found the trend equation. So using that trend equation, the question was forecast the next value of the trend in the series. Forecast the next value. That means they are asking, so here the data shows up to 2021. So they are requesting you to forecast for 2022, the next year. So anyone who did the forecast, you can put the answer in the chat box. What is the forecast for 2022? Okay, I have no answers, so that means you do not know the thing, right? So first I will tell how to do that. So I will go to my Excel file. This was the exercise we did last class, and we developed this particular trend equation, right? So now the question is, what is the forecast for 2022? The next value means 2022, because we have up to 2021. So the way is very simple. So for that, you have to first write the equation, trend equation. So that is yt is equal to 1.3 t. So first write the trend equation. Then you have to substitute the values. So in the next step, what you can do is, for this t, right, for the time, what amount will you substitute? That is my question. For this time, what amount will you substitute? So what is t for 2022? You can observe this table and you can guess the answer. For 2022, what is the value of t? I got only one answer from MS79. Any others? Yeah, your answers are correct. Thank you. So this is the t values. You know, we have to increase 1 unit for each year. For each period, we have to increase 1 unit. So 2021 means 5, right? 2021 is 5. So therefore 2022 must be 6. So the respective t value of 2022 is 6. Therefore, here we are going to substitute 6, right? So t is 6 here. Therefore, we are substituting t value should be 6, right?
So now what is the answer? So what is the final answer for the forecasted? What is this sales? What is the final value? Yeah, correct. 13.9. 13.9. So if you write 13.9 only, you will get half marks for the answer. What is the full answer? 13.9 what? So you have to be very careful about the unit measurement. Here the unit measurement is dollar millions, right? Dollar millions. So you have to write the full answer, $13.9 million, right? So the answer is $13 million. This is a full answer. If you forget to put rupees or dollars or million, you will lose answer, you will lose marks. So be careful. So this is how you have to do forecasting, right? So why we are doing this trend analysis is first finding the trend equation, and using that equation we can forecast to any future year or any future period. We can forecast to 2022, 2023, 24, 25, no problem. We have the equation, so we can forecast. I hope now you have understood that. Then there was another question. Forecast the sales for 2025. So now it is your turn. So now you can do the work and put the answer in the chat box. Using the same trend equation, forecast the sales for 2025. Right, I am getting some different answers. 17.8 is coming, 16.5 is coming, 17.1 is coming. Different answers are coming. Again, 66. So we check the answer. So 2025, right? So first of all, tell me 2005, what is the T number, the time, the T value for 2025. So definitely, you know, 2023, 2024, 2025. If the time value is 6 for 2022, then 7, 8, 9. 2025, the time value is 9. So then what you have to do, just put the formula and substitute the values. So here the time value is 9. So for T, you have to substitute 9. That is the only change. All the other things are same. You are only substituting 9 and you have to get the answer. 1.3 is to 9 plus 6.1. 17.8 is the correct answer. 17.8 million is the correct answer. Yes. So most of you have given 17.8. MS36, check your answer again. You put 17.9, maybe rounding errors. Right. So that is forecasting. So I hope now you understood that. Then next I gave you a big exercise. So I hope you have done that. So now I will not explain how to do, because last class I demonstrated how to do a similar exercise. Today I will show you the answers. So quickly I will do, so you can check the answers and you can verify your answer with my answer. But before that, there was a question, the first question. Look at the data. What sort of trend and seasonal pattern do you expect to emerge from the analysis of this data? This is a preliminary question. Normally, as a statistician, before going to the analysis, by just looking the data, you should be able to identify some pattern or trend. Just you are watching the data, only watching, and you can guess something, no? So here, that is the first impression. Then you can do the analysis and you can confirm your impression or your thought. So for here also they are asking, just by looking the table, what can you tell? What sort of trend can you imagine? Or are there any seasonal patterns? So anyone, can you answer for me using mic? Is it increasing trend, or whether is it decreasing trend, or whether is that constant movement? Any observation? If you can share, you can share with me. Or if you can find any seasonal variations by just watching this, you can tell. I have observed one seasonal variation. Okay, so I don't have time. Maybe in future, you may have the ability to explain by looking only the table. This is your first, maybe you don't have that expertise. Okay, I can tell you, see the numbers starting from 24.8. Then little it is increasing. No, see every quarter one, it is increasing. And see every quarter four, it is also increasing. So starting from 24.8 and it is finishing at 68.9. So I can tell there is an upward trend. It is increasing, right? It is increasing trend I can observe. And also if you see the last quarter, that is very high, no? Compared to all the other quarters, quarter number 4 sales is very high for all the years. So there's a seasonal trend, seasonal pattern. In quarter 4, sales is very high. Similarly, in quarter 1, sales are very low. So those 2 quarters have some seasonal variations, right? So if you can plot this data, you can observe this, right? Okay, that is just your ideas by looking at the table. Now I am moving to the next question, the years. So there's a seasonal trend, seasonal pattern. In quarter 4, sales is very high. Similarly, in quarter 1, sales are very low. So those 2 quarters have some seasonal variations, right? So if you can plot this data, you can observe this, right? Okay, that is just your ideas by looking at the table. Now I am moving to the next question. Numbering 2018 quarter 1 as 1. T should be 1. And quarter 4 of 2021, T should be 16. So you know the T values, how it is increasing. The question is, calculate the equation of the trend using linear regression. So you know how to do that. So yeah, I will quickly do that in my Excel so you can check your answer with my answer. So I have to transfer this table to my Excel file. So here I have transferred the values. So I have put the X value and I have copied my dependent variable values. Sales is the dependent variable, time is the independent variable. So there are 16 observations. So then you know what to do. You have to first calculate slope B1 and then you have to calculate B0 intercept. Then we can develop the trend equation. So for calculating slope and intercept, we have to calculate these two values, x squared and xy. So I can quickly calculate x squared. So these are the x squared values. Then I have to calculate xy values. So these are the xy values. Then I have to get the total because total is very important for doing the substitutions. Right, then I can, if I have the total values, I can do the slope calculation. So I will substitute the values. So sigma xy 7359.1, then sigma x 136 into sigma y, that is 772.8, divided by sample size 16. Then sigma x squared, that is 1496. That is sigma x squared, that is 136 to the power 2 divided by sample size 16. So anyone, can you tell me the answer for this? What is the slope? So put your answers in chat box. Then similarly, I have to find out the B0 values. So B0 sigma x divided by n. So sigma x here 136 divided by 16. Then slope value, we do not know that yet, into, sorry, sigma x divided by 16. Here sigma y, so it must be 772.8. So the answer will come. So if you have calculated the B1 slope, put the answer in the chat box. I am little bit speed because I have explained all these things in my previous class. (2.32) given by MS57, 2.3244 given by MS131. Yes, you are correct. But MS32, your answer is wrong, I think. So I can put the number 2.324. 2.324. I can put 2.32 also, no problem. That is also correct. But to get more accurate answer, I am putting 2.324. So when you are substituting this answer here, you can get the B0 value. So anyone, what is the B0 value? What is the intercept? $28.55. Okay, thank you, commas 132. 28.55. If that is wrong, please tell me. So now we have calculated B1 and B0. Then we can develop the equation. So the equation is y cap is equal to 28.55 plus 2.324 t. So that is the equation. Y cap is equal to 28.55 plus 2.324 T. Check whether your answers are correct. Okay, now you can take a screenshot if you want. These are the answers for that question, question B. Now I am moving to the next question. Question number 4. Use the regression equation calculated in question 3 to forecast the trend in sales for the 4 quarters of 2022. So again, they are asking a forecasting question. So it's very simple. They are asking the values for 2022, all the 4 quarters. So that is simple, no? So you know how to forecast those things. So I will quickly do that. So here they are asking for 2022 quarter 1, quarter 2, quarter 3, quarter 4 using the same formula. So you know the time values of quarter 1 will be 17, 18, 19, 20. So if you substitute these values, then you can get the Y value. For 2022 quarter 1, 28.55 plus 2.324 into 70. So that is how you have to do that. We are substituting time value in the equation. So the answer will be we have to substitute the T values respectively for all the 4 quarters. So these should be the answers. Right. Now it's a good time. Now tell me, I am now talking about the first value, 68.06. What is this the full answer or do we need to modify this? 68.06 what? What is the unit here? Unit measurement. For the last example, it was $1 million, right? $1 million. So for here, 68.06, what is the unit measurement? Yeah, thousands is the unit measurement. Therefore, the answer must be written in which manner, how you can write the answers, how you can write this 68.06. So here, 1000, because you can see sales here, sales in thousands. So they have given you the values in thousands. So you also have to write the values in same units. So 68.06 into 1000. So you have to multiply by 1000. So if you multiply this by 1000, then your answer must be 68.06 into 1000, right? You are multiplying by 1000. So 68,060. That is your answer, final answer, right? So that is very important. You have to multiply the answer into the units given, right? So I think it is rupees. So rupees 68,000, 70,000, 72,000, 75,000. These are the forecasted values, forecasted sales for the next 4 quarters, right? So hope you have understood this thing. So now I am moving to the next question. Question 5. Right. So question 5, using the equation. So now they have given you the trend equation. Time is 1 for the first quarter of 2015. So now they are asking you to calculate the trend for the fourth quarter of 2022. So please give the answer. I will not explain, you know what to do. So give the answer for the fourth quarter of 2022. Okay, right. So I got correct answers from MS57 and MS51 COM104. Again, MS111. No. 111, your answer is wrong. COM104, it is correct. Right. So it is a tricky question, but you should give more attention on that, because when you are attending MCQ questions, these type of questions will come, right? So in my section, that means time series analysis and statistical quality control, I will conduct one MCQ examination after finishing all this stuff. So you may have this type of questions. So you have to be more clear, more analytical to get the answer. So the key is finding the correct t value, right? If you can get the correct t value for 2022 fourth quarter, you can approach this question. So I am moving to Excel. So here I am copying the trend equation. So the trend equation is 43 plus 5.9 t. This is the trend equation, 43 plus 5.9 t. So and they give another information, that is 2015 quarter 1, the time is 1. The time value for 2015 quarter 1 is 1. Therefore quarter 2, you know how it goes. So it goes 2, 3, 4, likewise it goes, right? So it goes like that. So it goes like that. And 2022 quarter 4, what is the time value? The correct time value for 2022 quarter 4. Yeah. 32, because there are 8 years in between. So the correct time value is 32. That is very key point. If you are doing mistake in that, you will lose the marks. So now you know the t value. So now just apply it. So 43 plus 5.9 into 32. That's all. You are just substituting the correct t value. So what is the answer now? 5.9 into 32 plus 43 is 231.8. So 231.8. So here they did not talk anything about unit measurement. So you can just put 231.8, because they did not tell about dollars or rupees or thousands. They did not tell anything. Right? So just put number 231.8. So take a screenshot of this. And now I am going to another variation. Same question, right? So now you have found out the trend component of the time series for 2022 fourth quarter. Same question. Now I am adding one more analysis, the yellow color one. Forecast the sales for the fourth quarter of 2022. The same time but now I am asking you to forecast the sales. Previous question, forecast the trend. Trend you have found. Now I am asking forecast the sales of the same fourth quarter of 2022 when the seasonal index of the same quarter is 0.86. So now I am giving one more information. The seasonal value also I am giving you. So now you have to tell me the sales amount of the same quarter. Can anyone try this question? You have to apply the knowledge of time series models. Right? In previous class, you studied two models, additive model, multiplicative model. Using that knowledge and using this calculation, you can find the answer. I got one answer from MS79. So whether we will check whether it is correct. So I am going to Excel again. So now what you have calculated here is the trend component. The English letter is capital T. T means trend. So here they are telling you the seasonal index, right? The seasonal index for quarter 4 is how much? 0.86. So seasonal index means S, capital S. So that is they are giving you 0.86. And now they are asking you what is the value of sales, right? So in our previous class, we know that time series models, there are two models, additive model and multiplicative model. So multiplicative models tells The forecasted value is equal to trend component plus seasonal component plus cyclical component plus irregular component. That is the model, right? So here we have found out this T. Right, this trend component we have found out. So that is how much? 231.8. You have found out 231.8. This seasonal component, they have given you 0.86. Other two things they did not give, so don't worry about it. I also told you cyclical component and irregular component is out of your scope. If they give, you can calculate, otherwise no need to worry about it. So these two component values you know. So therefore, now you can calculate simply. So our model is y is equal to t into s. So therefore, y is equal to now 231.8, that is trend value. Seasonal value, they have given you 0.86. Yes, therefore the final answer is 231.8, 0.86, 199.35. Yes, or 348. This is the final sales. This is the sales value, not the trend value, sales value. Trend value is high, but because of seasonal fluctuations, your sales is coming down to 199.35 units. So this is the answer for that. So this is the final ultimate purpose of time series analysis. You should know how to calculate trend. You should know how to calculate seasonal variation, and you should know how to combine them. So now we have done the combination work, right? You know how to calculate the trend, you know, but seasonal variation, you did not study yet. Next class, you will study how to calculate seasonal index. After that, you can do this final multiplication works. Hope you have understood this. So all of you, if you have understood what I taught you so far, put yes in the chat box. Or if you have any questions, you can put the questions in the chat box, or you can ask through the mic. Right, okay. So that shows you have understood the concept. So now I am moving to the next one. So already we had completed 3 objectives. So now we have completed the 4th objective. So now you know how to use trend equation to forecast future time period, and you know how to not develop, how to adjust the forecast using seasonal indexes. So those 2 things you know now. So we have to now move to the next objective. So the next section is smoothing techniques, right? Smoothing techniques. So why you want to do this smoothing technique, right? So again, that technique also will help you to identify the trend, right? So if I want to show you some example, okay, I will show you a time series data. Okay, I will show you a time series data. So you can observe this data. So this is quarterly production data, quarterly production. So you know, if a variable has been ordered in sequence over time, it is called time series data. So this is production data, and yeah, quarterly production data from 2017 to 2021. So here, if you see the time chart or the line chart of this time series, I will show you that this is the time series graph. So first of all, can anyone tell me what is the trend here? Increasing or decreasing or constant? Yes, of course, increasing. We can tell, right, by just looking. It is, we can tell increasing, but there are so many fluctuations, up and downs, right? So this particular line is not a trend line. This line has so many up and downs. So you can see quarter 3 or quarter 4 is very high. Again, quarters, the next year, second quarter is very low. So many up and downs. So if we have a chart like this, it is very difficult for us to do forecasting. We want a straight line, right? If there is a straight line or equal to, very close to straight line, it is very easy to estimate. So therefore, one of our objective is to reduce these up and downs, reduce the fluctuations. For that purpose, we are doing a technique called smoothing technique. This smoothing technique, so here you can point out, smoothing techniques remove what? Seasonal variations and random fluctuations, right? So if there are so many up and downs because of seasonal variations or random events, smoothing technique will remove those things, right? So if you remove those things, your line will be a straight line, right? Like a trend line, it will be a straight line. If you remove those fluctuations, approximately it will be straight. So therefore, you have to study this smoothing techniques, how to smooth the data. So what is, so there are two methods, right? Two common methods of smoothing the time series. The first one is moving average, and the second one is exponential smoothing. So using these two methods, you can remove the fluctuations, remove the unnecessary seasonal variations from time series. So therefore, now first we are going to study about the first technique, moving average. So this is very important for you. So if you see your past papers, this moving average, more marks had been allocated to this moving average method. So 5.1, now we are studying about moving average. So they are telling the special name K period moving average. So what is that K? K means how many periods you are considering to get the average. So you know this method is about calculating average, right? So you have to calculate average. How many periods you are considering is this K. K means how many periods. So it can be two period, it can be three period moving average, or 4 period, or 5 period, or 6 period. So they will tell you how many period you have to consider for getting the average. So here, how you can do that is starting at point at period T and counting K periods backwards. That is the technique. So it may be complicated to you. I will explain how to do that. So a 3 period moving average. So here 3 period means you have to calculate the average of 3 periods. So how can you do that? This is the formula. Yt plus Yt minus 1 plus Yt minus 2 divided by 3. Simply, I will explain how to do that. This may be complicated. So I will quickly show this by Excel. So here they gave you an example of 3 period moving average. Right? So 3 period moving average, we are going to tell you. So now the question, for example, I will give you a question. You can simply understand what is the 3 period moving average of 2017 quarter 3. What is the 3 period moving average of 2017 quarter 3? So here you may know the formula. Now I will recall the formula. So here in the slides, they have given you the formula. Yt plus Yt minus 1 plus Yt minus 2, get the total, divided by 3. Why we are dividing by 3? Because it is 3 period moving average. So now I am going to Excel. So the moving average of 2017 quarter 3 is equal to, so the formula is within bracket Yt plus Yt minus 1 plus Yt minus 3 divided by 3. This is the formula. So that is equal to, so we are calculating for 2017 quarter 3. So that means we are calculating for quarter 3. So now tell me, what is the Yt value of quarter 3? So wait, I will again expand this for your easy understanding. So Yt means 2017 quarter 3. Then what is Yt minus 1? Don't put chat, quickly talk so I can quickly go. If T means the month for which you want to calculate. So the period for which you want to calculate. So T is 2017 quarter 3. So T minus 1.
Quarter 2.
Very good. 2017 quarter 2. Give me 1 minute. Right. So I got one answer also. So T minus 3, 2017 quarter 1. So we are going in reverse. We are going in reverse. So that means we are getting the total of 3 years and dividing by 3. So now you may understood that. So 2017 quarter 3, sorry, 3, 8 plus 6 plus 5 divided by 3. So that is 8 plus 6 plus 5, 19 divided by 3. So 19 divided by 3 is equal to 6 point something, 6.33. Thank you for the answer, MS131. So that is the moving average. So this is how you have to calculate moving average. So if it is 3 period, you have to get the total of 3 and divide by 3. If it is 4 period, get the total of 4 and divide by 4. So that is same principle you can apply to any number of periods. So hope you have understood this. So that's I wanted to explain how to calculate the moving average. So why we are calculating this moving average? So to remove the fluctuations in the time series and to smooth the data. So I'm going to explain this by one example. To forecast future production units, last 5-year annual production data were recorded. So this is the data which I showed you in Excel. So the question is calculate the 3-quarter, 5-quarter and 7-quarter moving average. So here they are giving 3 different time periods, 3-quarter, then 5-quarter, then 7-quarter. So this is the data. So I hope you have exercise copies with you or notebooks. Copy this data, then you also can do with me. Right? So it is easy for you to copy from my Excel file. So I will show you my Excel file. So copy the same layout. In your exercise books. Then we can continue. So first copy this data and put OK in the chat box so I can continue. Okay. So the first question is 3-period moving average. That was the first question. 3-period moving average. And the second question was 5 period. Third question was 7 period. So why they want to calculate different periods? There is an answer, reason for that. So I will tell later. And now we will calculate the 3-period moving average first. Okay. So 3-period means you have to get the average of every 3 months, every 3 quarters. So first we have to do the first average. We have to calculate the first average. So first average, we have to select the first 3 months and get the average. So what is the average of the first 3 months?
$6.33.
6.33. Very good. So this 6.33 you have to place in the middle, in the center point. So what is the center point for these 3 quarters?
Q2.
Very good. So quarter 2 is the center point. Therefore, you have to place the 6.33 in the center. Right. Then we have to calculate the average of the next 3 quarters. So what are the next 3 quarters? What are the next 3 quarters?
2017 Q4 and 2018 Q1 and Q2.
That is wrong, right? So if you go like that, you are some important adjustments may be missed. So don't go like that. So what you can do is when you want to calculate the next average, only remove the first quarter. Remove the first quarter from your calculation. Avoid it and add the next quarter. Remove the first and include one new. So the next calculation will be for Q2, Q3, and Q4, right? Removing the last one and adding another new one. That is, in that way you have to move. So because of that, it is called moving average. Why it is called moving average? You are moving one by one. You are moving one cell by one cell, right? So now tell me the average of the next 3 quarters.
8.
8. 1824 divided by 3. 8. Yes, 8 you have to place in the middle. So now what is the middle point? Q3 is the middle point. So that is 8, right? So in that way, what is the average of the next 3 quarters?
$7.66.
7.66. Very good. So if you round it, 7.67. So next 3 quarter means avoid the last one and add the new one. So in that way, you have to move one by one. You have to move. So quickly complete this table. Quickly, wait. I'm going to give you a break. So I will tell the task, then you can do that, right? Okay. So in that way, you are going to calculate the averages for 3 periods, right? So you can do that in break time. Now we will move to next one, 5-period moving average. So anyone tell me what is the first 5-period moving average? I got an answer called 14.6. So 5-period means you are going to calculate the averages of the first 5 quarters. One I got 14.6, one I got 6.8. So first 5
6.8.
mean, yeah, 6.8. So the first 5 years, 5 quarter average is 6.8. Where will you place that? What is the center part of this 5 quarters?
Quarter 3.
Very good. Quarter 3 is the center part. So that answer will come here. 6.8 will come here. So can anyone tell what is the next 5-period average?
6.4.
6.4. Very good. So that is for the next 5 quarters. So in that way, you have to calculate all the 5-period moving average, right? So now we are moving to 7-period average. So what is the first 7-period moving average? $6.28 is the answer coming. I will check that. So first 7-period moving average. So we are getting the average of the first 7 period now. Totally 7. Yeah. The average is, yeah, 6.29, I think, if you round it. So what is the center point of this?
Quarter 4.
Yes, quarter 4 is the center point for 7 period. So you have to put the average there, 6.29. What is the next 7-point moving average?
40.429.
Double check your answer.
7 is correct, sir.
7, no?
Yes, sir.
7. So the next 7 means you have to remove the first and add another one. So the next 7 period is 7. So likewise, now I am going to give you a break for 15 minutes. Now it is 11:57. So we are meeting again at 12:15. So complete all the balance time period. Complete all the balance time periods. And be ready for discussion. Because you need some practice in this part, because this quick calculation, when you are doing this, you will get some idea how to, every time, no need to type again and again, right? You are using scientific calculators, so you develop your own technique to quickly calculate these averages. In exam, you will have this big number of big table. So you have to be very speed to do this calculation. So therefore, I am giving you this practice. All of you practice this and be ready after 15 minutes for the further discussion. So calculate everything. Right, can you hear me?
Yes, sir.
Right, hope you have completed this table. So I will complete the 3-year periods first. So if you calculate all the 3-year moving averages, it will look like this. For the last and for the first, it will be blank. For 3-period average, the first cell and the last cell will be blank. So that is how you calculate it. So now, before going to 5 period, so I would like to show you a small difference between the original time series data and the calculated moving average. So if you draw a graph to the original data, it is like this. Already I showed you. So see the fluctuations. There are so many up and downs. This is the original data. So why we did moving average? We wanted to remove the fluctuations. So therefore we calculated 3-period moving average. So now I am going to draw a graph for both of these data. So you can see the difference. The red color one is the 3-period moving average. So when you are getting the average, some fluctuations have been smoothed, right? So this is called smoothing. So you can see here, this particular up and down have been removed from the data, right? So we have smoothed the data. So that is the difference between blue color line and red color line. If you want to smooth further, if you want to remove the fluctuations further, you can go to 5-period. So when you are increasing the number of periods to average, the fluctuations will go down, right? So we will check that also. So now we will do 5-year moving average. So I will find the other numbers. So the first 2 and the last 2 will be blank for 5 years. So now I will show you the graph of original and 5 years. Check the graph of the original and 5 years. See, this is red color one is the 5-year moving average line. Say almost it is equal to, it is approximately, it is a straight line. So simply there are no up and down. All the up and downs we have smoothed it, right? Original data, there were so many up and downs, fluctuations. But this 5-year moving average, we have reduced the fluctuations. And now we can tell the trend. It is an increasing trend. So this is the purpose of this moving average. If you find 7-year moving average, further it will reduce the fluctuations. So 7 also I will do, but I'm not going to draw the graph. If it is 7-period, first 3 and last 3 will be blank. So why we are calculating moving average? To find the trend, right? To remove the fluctuations, seasonal fluctuations, random fluctuations, right? Sometimes cyclical fluctuations. And to study the trend, we are using moving averages, right? That is the ultimate purpose of moving average, right? So I hope now you have understood this part. Do you have any questions so far in this moving average? If you have any doubts, you can ask. I hope not. If you have any questions, you can post in the chat box also. But actually, you must have some doubt here. We check that. Okay. So now I am going to introduce another concept under moving average. It is called centered moving average, right? Sometimes you may have this in your mind. With the even number of observations, what to do? That is the main problem. So I am going back to this. I am going to this example. So here we calculated 3 period, 5 period, 7 period. All these are odd numbers. You know what is odd numbers? 1, 3, 5, 7, 9. These are odd numbers. So you calculated odd number period 3, 5, 7. What about even number? If you are asked 4 period moving average, 6 period moving average, 8 period moving average, what to do? There will be a problem, right? So what problem you may face, we can see that by this example. So here I have given an example in your PowerPoint. So the same example I am going to do by Excel. So here they have given you 8 periods and respective sales. So the question is, calculate the 4 period moving average. 4 period. 4 means even number. So now you know what to do. You have to calculate the first 4 period moving average. Can anyone tell what is the first 4 period moving average?
19.
Yes, very good. 19. This 19, where will you place? What is the center point? What is the center point for these 4 periods? What is the center point? Middle, no? Center point means middle part. Yeah. You are giving me the answer like 2.5. 2.5 means you are considering this point. Middle point is exactly between 1 and 2 and 3 and 4. So this is the middle area, right? This is the middle point. So there you have to put 19. Average of first 4 period is 19. You are putting here. What is the next 4 period average? What is the next 4-period average? You know what you have to do? You have to remove the first one and you have to add another value. Yes, answer is 21.5. We check 21.5 correct. So where will you place that? In the middle. You will place in the middle point 21.5. So similarly, the next 4-period average is, I think, 17.5. If I am wrong, correct me. 17.5. So in this way, you have to insert the average values. But there's a problem. The problem is all these 4-period moving average are not connected to a certain period. Your manager comes and your manager asks, okay, what is the moving average of period number 3? So for period number 3, that is blank. There is no answer. Then he is asking, okay, what is the average of period number 4? Period number 4 also blank. So for all the period, there is no value. There are blank value. Why? The center point is somewhere else. So how to sort out this problem? Your moving average values are in the middle, not connected to a period, not related to a period. There is no meaning. If it is in the middle, there is no meaning. So how can you sort out this? Any brilliant student? Because your manager wants the value for number 3, value for number 4. If the number is odd number, no problem. This is for only even number. MS51, very good. That is the answer I expected. Any other answers? MS51 says, getting the total of these two, I am putting in blue color, 19 and 21.5. 131, thank you for your answer, but it cannot be correct. So MS51 says getting the total of these two and again getting the average, right? 19 plus 21.5. 19 plus 21.5 divided by 2. That is the idea of MS51. And put it in the middle. So 19 and 21.5, the middle is number 3. So put the answer in the center part. So that is how much? 20.25. So that is the appropriate way, most appropriate method to find out the average values for a certain period. So now tell me, what is the value for quarter 4, period 4? What is the value for period 4?
19.5.
That's exactly 19.5. So what you can do, get the average of 21.5 and 17.5. So 21.5 plus 17.5 divided by 2 equal to 19.5. So this is the idea. So that is why this particular column is called centered moving average, CMA. So this additional column you may need when your periods are even number period, right? In the previous example, it was odd numbers, 3 period average, 5 period, 7 period, all the numbers are odd numbers. But here the question is even number question, 4 period. So therefore, you have to calculate centered moving average, right? If you want to calculate centered moving average, then only the average values will be connected to a certain period. I hope now you have understood how you have to do that. So likewise, you can calculate for the other things, other periods. So I will now go to the PowerPoint. So here I explain how to do that. First, get the average of first 4 values and put it in the middle. Then again the next 4 values, again put it in the middle. But these middle points are not meaningful. Therefore, we are creating another column called centered moving average and adding 19 and 21.5 and put the answer in the middle. That middle is connected to period number 3. So in that way, you have to continue the process. So that will sort out the issues, right? So that is centered moving average. So this I will not teach today. This is the next part, exponential smoothing, right? So earlier I told you smoothing techniques. Today we learned about smoothing techniques. This smoothing can be done in 2 ways. One is moving average and the other one is exponential smoothing. So we have completed the moving average, right? So we have finished the moving average. And exponential smoothing, we have to study in our next class how to do exponential smoothing. And I hope you know the purpose of smoothing. So with that, I would like to wind up today's class. So if you have any questions, you can ask me. So others, if you have understood everything, you can put yes in the chat box and you can leave. Thank you very much. So I'll be here for another 5 minutes. If you want to ask any questions, you can ask. Next class will be probably on Wednesday. So this section is 5.2. It is about exponential smoothing, another smoothing technique. So this one also you need to study carefully. So what is this tool? This tool is doing a forecast, right, based on weighted average of current and past values, right? Weighted average of current and past values. So I can change this actually weighted averages of, wait, I'll show you. Okay. Rather than using current and past, we can tell weighted average of actual and forecasted values, right? So here you know what is weighted average. So we are going to use that technique to calculate, to forecast for future, and mostly it is used for immediate future. For example, if you have data set, if you have time series for 2021 up to December, using this method you can forecast for January, the immediate future, right? For mostly that is, for that purpose they are using this exponential smoothing, and this is the formula. So in the PowerPoint slide I uploaded in LMS, this formula, there was a small error. So here I have corrected that error. This is the correct formula. So you have to study this formula, right? So here the ET is exponentially smoothed value is equal to, you can see alpha here. This alpha means smoothing constant. So this constant, it will be decided by the statistician or your examiner, right? So they will give a value. The value must be between, you can see here, must be between 0 and 1. More than 0, less than 1. So that will be the smoothing value, maybe 0 0.3, 0 0.2 or 0 0.67. So they will give the value. So that value must be multiplied by y t minus 1. You know, t means current period, t minus 1 means previous period. So y means the actual value. So actual value of the previous period is multiplied by alpha, the first area, plus the second work 1 minus alpha. If the alpha is 0 0.3, 1 minus alpha is 0 0.7. So that 1 minus alpha multiplied by E t minus 1. You know, t minus 1 is the previous period. Capital E means the forecast or the smoothed value. The forecast value of previous period multiplied by 1 minus alpha. So if you get the total, then you can get the smoothed value, or you can use that for forecast even. That is the formula. So here I have given the explanations. So now we will do an example so you can understand. So this is the example: electricity purchase or electricity consumption. So they have given you the data from 2014 to 2021. So 8-year data is there, and the actual electricity purchases also there. So the question is, you are requested to smooth the values. So you are requested to smooth the values using alpha 0.3. So they have given you the alpha value also. So now we are going to do the smoothing work. So I will transfer this one to Excel. Right, you can observe here. So copy the data in your exercise book or your short notes. So copy this data, and I will tell you after that, put OK in the chat box. then I can explain how to calculate the smoothed exponential data. So copy and then put OK in the chat box. Okay. So this is the original data. So if you see the original data in the graph, so this is the graph. So you can see there are so many fluctuations. So now we are going to smooth the data. Then we can reduce these fluctuations and we can expect to derive a trend line, right? This is not a trend line. There are so many up and downs. So now we are going to calculate the smoothed values. So here you can see the formula I have put. So expected exponential smoothed value or the forecasted value is equal to alpha into y t minus 1 plus 1 minus alpha into e t minus 1. So this smoothing forecast we cannot do for 2014. The first period we cannot find out because T minus 1 data is not available for 2014. If 2014 is T, then T minus 1 is 2013. So 2013 value is not there. Therefore, we don't calculate for the first. The first smooth value will be blank. So we will start from the second value. The second value again will be equal to the actual value of the previous year, right? The second value will be equal to the actual value of the previous year. So that is 815. So these two will be same. Because last year there was no any forecast, so we are putting the same value of the previous actual to the second period 2015. So now we are going to start from 2016, right? So now I am going to calculate for 2016. So for that I am going to use this formula. So ET, so here the time is 2016. We are going to calculate the exponential smooth value for 2016. Here, the first part, I will do the first part. So what is the alpha value here? They have given the alpha value 0.3. Alpha value is 0.3 into y t minus 1. Y is the actual, right? Y means actual. Actual value of the previous time period. Can anyone tell me the actual electricity purchase of the previous time period? $8.15 or $8.26. Right. So to make it simple, I can tell like that. Our time period is 2016. The t value is 2016. So t minus 1, what is t minus 1? If the t is 2016, t minus 1, 2015. So actual value of 2015. Here 1 minus alpha, if alpha is 0.3, right? Then 1 minus alpha 0.3. Again, E t minus 1, t minus 1 is 2050. So in the next line, now tell me what is the actual value of 2050. So as you told in the chat box, the actual value of 2015 is, you can see here, this is 2015. So I am marking in blue color. So actual value of 2015 is 826. That is the actual of the previous period. So that is 826. Then 1 minus 0.3 is equal to 0.7 into, what is the forecasted value of 2015? Exponential value. What is the forecasted or the exponential smooth value of 2015? Very good. So this is the 815, right? This 815 is the forecasted value of the previous year. This 826 is the actual value. 815 is the forecasted value or the smoothed value. So 815 we have to put 815. So now if you solve this, you can find out the answer. Tell me the answer. Okay, very good. So I will do that. So that is 0.3 into 6 plus 0.7 into 815 is equal to, very good, 818.3. That is the answer, final answer. So this you have to put here, 818.3. So the exponentially smoothed value for 2016 is 818.30. So now you can observe here, we have done this forecasting using two values, right? The first value is 8626. That is the previous year actual value. Excuse me. Right. So we are calculating using two values. One value is 826. That is the previous year actual value. So for that value, we are giving 0.3 as the weightage. So we are giving less weightage to the actual value. Then we are using the second value 8115. So for that we are giving weightage of 0.7. So for the forecasted value, we are giving 0.7 weightage. So we are giving two different weightage. So we are giving low weightage for the actual and we are giving high weightage for the forecast. This is how you have to do the exponential smoothing, right? So that is the idea. So now can you tell me what is the expected or the exponential smooth value of 2017, the next year? What is the expected value of 2017? So I am getting the answer 796.31. So not different answer. So I think that is correct. So 745, 1 minus 3 into 0.7 into 818.3. Right, so your answer is correct. 796.31. 796.31. So likewise, you have to calculate the smoothing values, smoothed values for the next 4 periods. So I will do that quickly. So you can do and you can compare your answer with my answer. $790.27, yes, correct. Then it must be 804, 814, 819. So these are the values. These are the smoothed values. Be careful about the smoothing constant. Here the smoothing constant is 0.3. Sometimes they will give 0.4 or 0.2. So based on the constant, you have to do the calculation. So now I can compare these two values. So now I can compare these two values. So you can observe the difference. The blue color line is the original data where there were so many up and downs, fluctuations. The red color line is the smoothed line, right? So we have smoothed the data. So you can see the fluctuations have been reduced, right? So this is the purpose of smoothing the data. For different constant, for different alpha values, you may have different trend lines. So when you are decreasing the alpha, the trend line will be more and more smoothed, more and more linear, straight line. When you increase the alpha value, the fluctuations also will increase. So I can show you the difference for your understanding. Right. So here we have used the alpha value 0.3, right? So I will show you if you change the alpha value, what will happen, right? If you change the alpha value, what will happen? I will show you now. Right. So now I will draw the graphs. So you can see if the alpha is 0.3, this is the red color one is the smooth line. So I will change the alpha to 0.4. See the difference. Fluctuation is increasing. 0.5. See, it is increasing. 0.6, more fluctuation. 0.7, more fluctuation. 0.8, very high. 0.9, so very high. So when you are increasing the alpha values, the fluctuations will increase. When you are reducing the alpha values 0.3, the fluctuations will reduce. So if it is 0.2, almost a trend line, a straight line. 0.1, no more fluctuations. So you can see. So basically they will set at 0.3 or 0.4 to reduce the fluctuations. So that is how, that is a small explanation about the alpha values, right? So going back to the slide. So this was the example we did, and in your PowerPoint slide, in your handout, the question 6 will be there. So these are some data, right? So monthly employment, unemployment rates for 2021. So you are required to forecast unemployment rate for January 2002. Using this data, you are going to forecast using exponential smoothing with alpha is 0.4. Alpha is 0.4. You are going to forecast for January 2022. They have helped you by giving the forecasted unemployment rate for December is 7.28. So they have given you the data. The forecasted unemployment rate using exponential smoothing was 7.28. So the question is, what is the forecasted value for January 2022? Can anyone do this and give me the answer? Very simple work. The data is very length data, right? But you don't need all this data. You need only 1 or 2 data. So I'll give you 2 minutes, find the answer and put in chat box. So 1.28 is the answer given by many students. So I will check that. I will check that. Right. So here the question is, they are asking you to calculate the forecast for January 2022. Right. So if you want to calculate for January 2022, you need the data of December 2021. That is enough. You don't need the previous data, right? So what do you need? You only need about December 2021. So this is enough. So this is the actual value. 7.3 is the actual value. So you need the forecasted value also. So that they have given here. Forecasted value they have given. Otherwise, you have to calculate from January. That is very big task. So here they, for easy purpose, they have given that also. So using these two values, you can simply calculate it. So we will now calculate. So I will calculate here. Okay, I will do the calculation here. So now we are going to calculate for the time is January 2022. That is the time frame. So we want to calculate. So alpha value they have given clearly 0.4. Alpha is 0.4 into. So the y must be t minus 1, that is December 2021. Previous year, previous month actual value. 1 minus alpha we know 0.6 into the expected value of the exponential smooth value or the expected value of December 2021. So this is the formula you need to apply. So now you know the answers. The last month actual data, actual unemployment rate was 7.3. Similarly, last month forecasted unemployment rate was 7.28. So now you can get the answer. So the answer is 0.4 into 7.3 plus 0.6 into 7.28. 7.288. So 7.29. So this is the expected value or the forecasted value, forecasted unemployment rate for January 2022. The immediate month, next month is January 2022. So you can do the forecast like this. So very good. So you did it correct, all of you. I hope you understood this part, right? That was question 6. Okay. So now we have completed the learning objective number 5, compute a moving average, right? So you have, now you know how to compute moving average, and also you know how to do exponential smoothing using exponential smoothing tools, right? That is also done. So now we are going to the next learning objective. That is the next part, determining seasonal index. So previous class we discussed about determining trend component, determining trend equation we did last class. So again I am reminding you, this trend and seasonal are your scope. So last class we have completed trend. You know how to calculate trend equation. So this class we are going to study about seasonal index, how to determine it, how to calculate it, right? So last class in exercise they gave the seasonal index, but actually you have to calculate it. So therefore today I will tell you how to calculate it. There are so many methods to calculate the seasonal index. So out of those methods, we are going to study about this ratio to moving average method. So using this method, we are going to calculate. So you are familiar with this name, moving average. You know what it is. So last class we have clearly discussed about it. So therefore it is easy to you to use that method and to calculate a seasonal index. So as you know, seasonal variation may occur within a year. You know, it is less than 1 year time. Within a year, you can observe seasonal variations, or even within a shorter time interval. To measure the seasonal effect, we want to calculate, or we want to construct seasonal indexes. So if we want to calculate, if we want to measure the seasonal effect, definitely we want to calculate seasonal index, that you know. In other words, seasonal indexes express the degree to which seasons differ from one to one. So if you want to compare different seasons, this seasonal index will help you, because in the first class you gave me interpretations about different seasonal index. I requested quarter 1 1.74, quarter 2, right? So quarter 2 0.91. So I gave you different index and I requested you to interpret it. So you interpreted quarter 1 74% higher than the normal trend. Quarter 2 9% lower, because 0.91 means if you subtract from 1 it is 0.09 minus. So 9% lower than the trend. So you can compare different quarters by using these seasonal indexes, right? So therefore it is very helpful to us. So now by one example I will demonstrate how to calculate this seasonal index. So this is a data set. The following table shows the quarterly sales for Toys International Company for 3 years, 2019, 20, 21. Give me 1 minute. Right. So 3-year data have been given to you. So the question is, determine a quarterly seasonal index. So quarterly seasonal index, you have to determine using which method? Using the ratio to moving average method. So that is the only method I will explain, and it is there in your syllabus. Other methods you don't need to study. So now we will see how to calculate it. So for that, I will take you to the Excel. Right. Right. So this is the Excel file. So this is the original data. So original data is in a tabular form, but this form is not helpful to us. So we have to rearrange the data in a table like this. So put 1, 2, 3, 4, 5, 6 columns in your exercise book. Put 6 columns: year, quarter, sales, and remember here they have given quarter. So they are asking you quarterly seasonal index. So how many quarters in a year? There are 4 quarters. So 4 quarters means even number. So you have to find out moving average, 4 quarter moving average. So therefore, if it is even number, you have to calculate additional column centered moving average. Therefore, year, quarter, sales, 4 quarter moving average, then another column for centered moving average. The last column, leave it blank. I will tell what to do. So develop this table in your copy and copy the actual data. Put the quarter number, put the sales, and then put OK in the chat box. So we can continue thereafter. So develop this table in your copy. The table is in a red color. And then after developing, put OK in the chat box. Okay. After developing the table, now you have to do, there are some steps. So I will tell you the steps one by one. Step number 1, you have to calculate the moving average, because you know we are going to calculate seasonal index using ratio to moving average method. Therefore, the first step is to calculate moving averages. Or if it is an odd number, you can calculate moving average. If it is an even number, you have to calculate centered moving averages for possible each period. Right? So that is the step number 1. So you are going to calculate moving average or uncentered moving average. So now you are going to complete column number 4 and 5, which is in yellow color. You are going to complete column 4 and 5. So can anyone tell me what is the centered moving average for 2019 quarter 3? Can anyone tell me what is the centered moving average for 2019 quarter 3? Because the first will be blank, the second also will be blank. I will not, I don't need to teach this because I have taught you this in last class. So you can quickly tell me what is the centered moving average for 2019 quarter 3. $7.76 answer is coming 131 144 MS4. I thank you for your answers. So we will check that. So the average of the first 4 quarters, that is 9.6. So average must be placed in the middle part. $9.575. So here put your answers in 3 decimals, right? So that will be helpful to you. Put all your answers in this table in 3 decimals. If you round to 2 decimal or 1 decimal, your final table will be complicated. So therefore, better keep your answers in 3 decimals. Then the next average is 9.6. So if you get the center moving average to these 2 values, then it must be 9.59. Your answer is 7.76. Why your answer is 7.76? What is the wrong? Is whether my answer is wrong or your answer is wrong? Double check. Statistics you must have practice, otherwise you can't do that. MS131, 144, MS04. What is that 7.76? First 3 quarter value. That is wrong. Why? We are doing 4 quarter average, no? We are doing 4 quarter moving average. So you have to be very careful about the question. See, the question says determine what? Determine a quarterly seasonal index. So for each quarter, you have to give quarterly seasonal index. So there are 4 quarters. If there are 4 quarters, your period is 4. 4 period average. You have to get the average of 4. Then tell me, If you want to calculate monthly seasonal index, what is the period? Talk in mic. If you want to calculate monthly seasonal index, what is the period number? If it is quarterly, 4. If it is monthly, yes, thank you, MS 147, 12. If it is monthly, 12. Very good. Then weekly seasonal index. Weekly. Week 1, week 2, week 3, week 4. Assume there are 4 weeks in a month. So weekly seasonal index, what is the number?
48.
That is for year, no? If you are considering monthly data, how many weeks in a month?
4.
So if you are considering month, then 4. Week 1, week 2, week 3, week 4. Again, week 1, week 2, week 3, week 4. So likewise, the data will go. So 4. If it is daily seasonal index, so here you are considering week, right? So day 1, day 2, day 3, day 4, day 5, day 6, day 7. Again, day 1, day 2, day 3, day 4, day 5, day 6, day 7. So likewise, it is rotating. So daily seasonal index, what is the time period? Yeah.
7.
If it is weekly, considering 7. If you are considering for monthly, 30. So therefore, be careful about this number system. So for quarterly seasonal index, and we are considering year. So here we are giving year. So how many year in a quarter? How many quarters in a year? 4. 4 quarters. Therefore, 4 period moving average. Yesterday, for explanation purpose, I explained about 3 quarter, but remind that 4 quarter must be your time period. Therefore, if you are getting 4 quarters, then these will be the answers. So now have you understood MS 131, 144, MS 04? Right, I hope you have understood this. So complete this table, the yellow color, 2 columns, complete all the values and find out the centered moving averages, and then put OK in the chat box so I can go to the next step. Okay, right. So I hope you have completed. So I will do quickly, then you can compare your answers with my answer. The first and last will be blank. First 2 and last 2 will be blank. Yeah, last 2. Right, so these are the values. So I will zoom out. So check whether these values are correct with your values. So this is step number 1. If there are any wrong values, tell me. Right now, going back to step number 2, right? So step number 2, so after you have calculated these things, so now you are going to calculate another important called specific seasonal. So you have to calculate the seasonal effect for each quarter, right? You are going to calculate the seasonal effect for each specific quarter. Therefore, they are telling specific seasonal. So how you can calculate? So you can divide the original sales, divide the original sales value by the moving average value, right? So divide the original sales by the moving average or centered moving average. So what you did last. So that is the step number 2. So I am going to the Excel file. So therefore now we are going to the last column, name must be specific seasonal, right? So now we are going to calculate that. We are going to calculate the last column, specific seasonal. So you know, first 2 values will be blank because we have no data, and last 2 values also will be blank because we have no data for that. So we have to start from 2019 quarter 3, specific seasonal. So this is the formula, specific seasonal. Sales divided by centered moving average. Sales divided by centered moving average. So what will be the value for quarter 3, 2019 quarter 3? Sales divided by centered moving average. Anyone? $1.126, right? Okay. Hello? Right, okay. So this must be, you have to divide sales by centered moving average. So 1.126 is the correct answer. So complete all the other specific seasonal values. I also will do that with you. Keep your answers in 3 decimal places. So your answers must look like these exactly. So double check whether it is correct. 1.126, 1.558, 0.733, 0.590, 1.143, 1.466, 0.801, 0.615. So hope you have completed this, right? So divide the sales by respective centered moving average. So these are the seasonal index for each quarter, right? These are the seasonal index for each quarter. But the problem is, say this is 1.126, that is for 2019 quarter 3. At the same time, 2020 quarter 3 has another value 1.143. So same quarter 3 has two values, 1.126 and 1.143. Similarly, quarter 4 2019 value is 1.558, 2020 value is 1.466. So therefore that also for quarter 4 also we have two values. So if we have these values, two values for each quarter, we cannot forecast, right? So we must have one value, only one index. So what is the next step? So again, we are going to do some averaging works in order to get only one seasonal index for each quarter. So therefore, now we are going to step number 3. So this is, we have completed step number 2. Now we are going to step number 3. The specific seasonals are organized in a table. This table will help us locate the specific seasonals for the corresponding quarters. So now we are going to reorganize our answers in another table. So from that table, we can find out one seasonal index for each quarter. That is step number 3. So now we are going to rearrange this in this particular table. So develop a table like this. So there must be 1, 2, 3, 4, 5, 6, 6 columns. So put the year 2018, 19, 20, and copy paste the seasonal specific seasonals you calculated here. Right, copy paste the specific seasonals you calculated in step number 2. So you know, okay, we will do from the first, develop the table. I'll give you some time. Develop this table. 1, 2, 3, 4, 5, 6 columns. 1, 2, 3, 4, 5, 6, 7, 8 rows. 6 columns, 8 rows. Develop the table first. After developing this, then what you can do is just copy paste your answers in step number 2. You got in step number 2. So what will be the answer for this particular cell? Anyone? Hello? So anyone tell me what will be the answer for this first cell? What is the specific seasonal of 2018 quarter one? Yes, very good. MS 147. 2018 quarter one. Sorry, 2019. 2019, 20, 21. 2019 quarter one. There is no answer. No answer, right? Here you can see there is no answer. 2019 quarter two also no answer because we don't have data to calculate that. Only we have answer from 2019 quarter three. Therefore, 2019 quarter one will be blank. Then 2019 quarter two also will be blank. Then 2019 quarter three, 1.126. So that is just we are copy paste. We are copying and pasting the answers simply from this table. This is this answer. 1.126 comes to 2019 quarter three. Then quarter four, 1.158. So likewise, just copy your answers in this table. Again, for the last quarters, there will be no answers. Last quarter also will be blank. So you can observe here, for each quarter, we have two values. That was the problem. For each quarter, we had two values. So now we are going to get the average. So getting the average will make your process easy. So can you complete these two? Calculating average is simple, no? Easy work for you. So get the total and then get the average and then put OK in the chat box. Get the total and then get the average and then put OK in the chat box. So I hope you have completed that. So I have to go a little bit fast. 10:14. Right. So total, you can get the total. So check whether these values are okay, correct with your values. So you have, now we have the average value, right? So average value for each quarter. But before finalizing the seasonal index, we have one more step. So that I am going to the PowerPoint. Step number 4. The 4-quarter seasonal index, the 4 quarterly means should theoretically total 4. That is the condition. Because we have 4 quarters. 4 quarters means the total of the average must be 4. Right? It cannot increase, it cannot decrease. Exactly, it should be 4. Right? Because average for 1 quarter is 1, so therefore it must be 4. If not, if that is not 4, we have to correct it, right? So therefore, first we have to check whether it is 4. We have to check the total. If it is 4, no problem. If it is not 4, then we have to adjust it using a correction factor. So we have to calculate a correction factor, and using that factor, we have to adjust the total value. That is the last step. So therefore, I'm going to Excel and I am getting the total now. So if you get the total of these 4 averages, it is 4.0. 4.017. 4.017, that is greater than 4. So theoretically, there is a violation. It cannot be 4.017. It has to be 4. So what you can do is the next step. You have to calculate the correction factor. So all of you write this. You have to calculate a correction factor. So what is the formula for the correction factor? 4 divided by total of 4 means. 4 divided by total of 4 means. So that means 4 divided by 4.017. 4 divided by 4.017. So can you tell me the answer? What is the correction factor?
0.99.
0.99. Wait, we'll check that. Yes, if you divide that 4 divided by 4.017, 0.9958. Better you keep 4 decimals, right? Because it is very close to 1. Therefore, better have 4 decimals for this correction factor. So now we have found the correction factor. So now what we can do? We have to find out the adjusted mean values. Adjusted mean values. So the first mean value is 0.767. This is the first mean value, 0.767. So multiply it. So we have to multiply that by our correction factor. Our correction factor is 0.099. What's that? 58. So multiply each averages by this correction factor. Multiply all the averages by the correction factor and put the answers. What you got? Put the answers for quarter 1, quarter 2, quarter 3, quarter 4. What are the corrected or adjusted averages? So multiply all the average by 0.9958. Right, so you are getting the answers. So I will put the answers. Thank you for your answers. Check whether it is correct. Zero point 0.764, 0.601, 600, 1.130, 1.1. Okay, correct answers. Sorry. So now if you get the total, of these adjusted averages, it will be equal to 4 or 3.99 or 4.01. So 3.998, no problem. 3.998 is no problem. Very close, right? It will be 3.998 or 999 or 4.01 or 4.02. Because of rounding errors, because I am doing in Excel, I get exactly 4. You are doing in calculators, you can get very close answers. Anyhow, it will be very close to 4. That is important. So these are the seasonal indices, right? So that was the question. Determine the seasonal index, right? Determine the seasonal index. So you have now calculated the seasonal index. Quarter 1, 0.764. Quarter 2, 0.6. Quarter 3, 1.13. And quarter 4, 1.506. So that I have summarized the answers here. So this is your final answer. So up to now, have you all understood what we learned today? How to do the seasonal, how to calculate seasonal variations. So we have 4 steps. Step number 1, develop this table and find out the moving average. Step number 1. If it is even number, calculate centered moving average. Step number 2, you have to calculate the specific seasonal for each quarter. What is the formula? Sales, the respective value divided by centered moving average. That is step number 2. Step number 3, develop in a new table and rearrange the quarter seasonal indexes and then get the total and get the average. The total of this average must be equal to 4. If not, you have to calculate the correction factor. That is step number 4. Calculate the correction factor 4 divided by total of 4 averages and multiply all the mean values by the correction factor. So at last, finally, you will get the seasonal indices for each quarter. Then this total must be equal to 4. So you have to summarize the answer like this. So this is the entire steps for calculating seasonal indexes. So if you have understood so far, put yes in the chat box. If you have any questions, you can put in chat box now. Okay, right. Daraj sir's lecture will start at 10:45, right? So we have 5 to 10 minutes more. So only one discussion is pending. So with that, I can stop this class. Daraj sir's class will start at 10:45. Right. So before leaving, again, I'm going to ask the same question which I asked in the first class. What is the interpretation of this? What is the interpretation of quarter 1 seasonal index 0.764? How can interpret it? Anyone? You can, this is interpretation is very big, so you can talk to me over the mic. I hope you have, you may forgot it, right? MS 147, no, that is wrong interpretation. Simple, what you can do is, I don't know whether I have the answer here. No, what you can do is, from the index, delete, subtract 1. From the index, subtract 1. So then answer is minus 23.6. Then what you can do is, so I put this like this, 0 0.71 minus 0 0.764. That is the first step. Oh, no. From the answer, deduct minus 1. So the answer will be minus 0.236. Then what you can do is minus 0.236 multiply by 100. Multiply by 100, right? Then you will get the answer 23.6. So that is percentage. So from the index, just deduct 1. So if your answer is minus, then the sales will go down. If the answer is plus, sales will increase. That is the interpretation. So for quarter 1, sales will go down by 23.6%. For quarter 2, anyone can anyone tell me whether sales will increase or sales will decrease in quarter 2? By how much?
Decrease by 40%.
Very good. Decrease by 40%. So 0.6 minus 1, that is equal to minus 4. So minus 0.4 into 100, that is 40%. So very good. In quarter 2, sales will go down by 40%. So in quarter 3, opposite, it will be plus 1.13 minus 1. Yes, very good, COM104, 13% increase. So in quarter 3, 13%. Here the answer will be 0.13. So 0.13 into 100 is 13%. So in quarter 3, 13% sales will increase compared to normal situation. In quarter 4, 50.6% increase compared to normal trend. Sales will increase by 56%. So these are the benefits of seasonal index calculation. So you can forecast for each quarter what will be the seasonal changes. So therefore, I have given you the interpretations. Sales for the first quarter are 23.6% below the typical quarter, below the normal quarter. Then say quarter 2, that is 40% below. Quarter 3, that is 13% up, above, high. Quarter 4, that is 50.6 above, up. So these are the benefits of seasonal index calculations. So with that, I would like to conclude this class. Only a small section is pending, so you know that now we have completed the 6th objective. We have completed how to determine and how to interpret seasonal index. We have completed. So a small portion is pending, deseasonalization of data. So that I will record a video and upload to LMS, a very small part. So by watching that video, you can understand how you can deseasonalize. the reverse way, right? Then with that, all the learning objectives will be completed and this particular subject will be completed. So our next class most probably will be on Friday. We will start my last area, statistical quality control. I hope to start that on Friday. So with that, I would like to conclude today's session. Thank you. If you have any questions, you can ask the questions. Others, you can leave. So far, you have studied about calculating seasonal index and interpreting those indices, right? So now, you should know the uses of these seasonal indexes, right? So the seasonal index for a particular month indicates how that month performs relative to the year as a whole. So assume you are calculating seasonal index for months. There are 12 months, so you are calculating seasonal index for 12 months. So what does that mean? So index of January, right? For example, if the seasonal index for January is if the seasonal index for January is, for example, 1.23. So 1.23 means you know how to interpret it. You have to deduct 1. So that is 0.23. So into 100. So 23%. So in January, 23%, the value will be high compared to a typical year, right? A typical month. So that is the interpretation. Generally, when comparing to that year as a whole, so when you are comparing the trend or when you are comparing the yearly data, January sales will be increased by 23%. That is the interpretation for seasonal index. So similarly, you can interpret the quarterly index, weekly index, daily index, no problem. You can interpret in the same way. So there are two uses for this seasonal index. The first use is seasonalizing, to seasonalize data. So already you have done that, but anyhow, I will do that again. So you know that in time series, right? So we are studying time series with two, especially the multiplicative model. We are studying two components, trend and seasonal. So when you have this trend, right? When you know the trend can be known by using the trend equation. So when you know the trend, because trend only will not give you a correct answer. You have to multiply the trend by seasonal index. Why you are multiplying? Then only you can forecast the actual sales. Trend alone will not help you. Trend multiplied by seasonal index, that will help you. So when you are multiplying that, what you are doing? You are seasonalizing the data. This process, multiplying by S, seasonal index, is called seasonalization. You are seasonalizing a data. Data means you have trend data. So you are seasonalizing the trend data by multiplying by S. That will give you seasonalized forecast, because forecast must have seasonal impact also. So that is the first use. You have a trend, multiply by S. So you are seasonalizing the data. You are getting the accurate forecast. That is the first use, right? So for that use, there is a exercise, I think. Forecast the sales for quarter one of 2022, right? So this particular example was derived from your previous exercise, right? So you did a previous exercise, no? There's this one. This particular example, it was derived so here you have data from 2019 to 2021. So from this data, you have found the seasonal index for quarter one, quarter two, quarter three, quarter four. So now the question is, they have given you the trend equation. Y cap is equal to 2.87 plus 2.76 T. So using this trend equation and using the seasonal index you calculated in the previous example, the question is forecast the sales for quarter one of 2022. So that is simple, already you have done like this. So pause the video and do your work yourself, work on your own, and then compare your answer with my answer. So now I am going to this I'm going to do this. Okay, so I will do that here. So the equation they have given, y is equal to 2.87 plus 2.76 t. So that is the trend equation they gave. So now the question is, you have to forecast for 2022 quarter one. So therefore, you know, sorry, this is not y, this is actually this is trend, right? Y cap or trend. So this is trend equation they have given you. So therefore, you know, this is the model y is equal to trend into s. This is the time series model using multiplicative methodology. So first we have to find out the trend. So to find out the trend, they have given you the trend equation. So you know what to do. Trend is equal to 2.87 plus within bracket 2.76 multiplied by t. So this t is the time value for 2022 quarter one. So you have to guess, right? You have to guess this time value. So the data set starts in 2019. Data set starts in 2019 quarter one. So, and it goes up to, so this should be 1, right? This should be 1. 2019 quarter one should be 1. Therefore, 2022 quarter one must be 30. If I am not wrong, it should be 30. 2019, 20, 21, 4 into 3, 12, yeah, 30. So this T must be 13. So then you can get the answer. Trend is equal to 2.87 plus 2.76 into 30. Yes, trend is equal to 38.75. So using the trend equation, now you have calculated the trend value only. Trend component you have calculated. So this is the time series model. So now you have calculated only the trend value. Y is equal to 38.75 multiplied by the seasonal component. Seasonal component of what? Because you are calculating for 2022 quarter one. Therefore, you have to insert the seasonal index of quarter one. So you have 4 seasonal index. So you calculated that. So quarter one index is 76.4. That means 0.764. So you can double check that in our previous working. Here, this is the summary of our seasonal index. Quarter 1 index is 0.764. Therefore, seasonal index is 0.764. This is the trend component 38.75, seasonal component 0.764. So if you multiply both, you can get the final answer 38.75 into 0.764. So 29.605. This is the final answer 29.765. And you have to be careful about the unit measurement. So if you check the data was given in $1 million. So this is 29.605 million. This is the final answer, right? So in this way, you have to calculate, you have to find the exact forecast. So this process, this is the first usage of seasonal index. What is the first use? To seasonalize data. So you have an example how to seasonalize it. Okay. The second use is deseasonalizing data. So before that, I want to remind you, now you have completed the sixth objective, determine and interpret a set of seasonal index. You have completed. So now we are moving to the last objective, deseasonalize data using a seasonal index. That means the usage to second use. Second use is opposite, the reverse way, deseasonalize. So what is that? Why you want to deseasonalize? Because there's a reason. So if you see this data, this particular data set, these are the actual values. So for example, I'll talk about Quarter 1. Quarter 1 of 2019, $7 million. I'm talking about this $7 million. This $7 million is what? Is the actual data. This has incorporated seasonal variation, right? Because you know each and every quarter there's a seasonal effect. So this $7 million incorporated two components. This $7 million has two components. One is trend component, one is seasonal component. Both are there. But as a manager, as a sales manager, sometimes you may want to know, okay, if there is no seasonal effect, what would be my actual sales? Because of seasonal effect, 7 million. If there is no seasonal effect, how much it should be? So that means the managers sometimes they want to eliminate this seasonal value from this 7 million. They only want to know about trend, right? They want to remove all the seasonal variation and they only want to check the trend only. For example, suddenly December sales is very high. So you can go and you can, as a sales manager, you can tell your top management, this December the sales have increased. So I have achieved higher sales. Then you can demand high commission for that. You can tell I perform very well in the market. So then because of that, my sales are very high. Then the top management will tell, no, not like that. December sales is high, okay, but it can be seasonal effect also. Better remove the seasonal component and then show the correct amount. Then you have to remove the seasonal component and you have to check what is the actual sales. That is the actual trend, whether it increased or not. So therefore, the second usage of seasonal index is deseasonalization, removing the seasonal component from a particular sales or particular value. So that is also simple, right? Removing the sales, right? So you know the same model you can apply here. So you know that time series model, multiplicative model, actual sales is equal to trend into seasonalization. So now the management tells they don't want seasonal effect. They don't want seasonal effect. They only want what? They only need the trend. They only need the trend. They don't want seasonal effect. So what you can do? So you can rearrange the formula, right? So if you want the trend, then trend is equal to y divided by s. This s has to go that side. This s has to go left side, then it has to be divided from y. Then you can get the t value, right? So both is possible. Both way, seasonal index will help you to seasonalize or to deseasonalize. So for that, there's a example, I think. This is what I explained to you. So the reason for deseasonalizing the sales series, why you want to deseasonalize, is to remove the seasonal fluctuations from the data set. So if you want to study the trend, if you want to study the cycle, if you want to study the long-term components, if you want to study about trend and cycle, you have to remove the seasonal variations. So if you want to remove the seasonal variations, you have to deseasonalize the data. So right, so therefore they have given you one example, the same example. So they are asking you to find out the deseasonalized sales, because these sales values have included seasonal component, right? So they want to calculate the deseasonalized sales without seasonal effect. They want to calculate. So therefore, copy this table in your exercise copy. And now I'm going to pause this video and copy this table in your exercise copy, then play the video. Right, so this is the actual data. So I have copied the sales from the table, and I have put the seasonal index you calculated in that example, right? The index. So here you can see one by one you have to copy paste the index. So for the quarter one, 0.764 is the 0.764 is the quarter one seasonal index. The same index you have to again put for the next first quarter. Again, the same index for next first quarter. All the first quarters must have the same seasonal index, right? Because we averaged and we calculated it. So therefore, same index we have to put for all the other things. Then others 0.60. So I think I have the value here, right? Then 0.600 for the second quarter. Then 1.13 for the third quarter. Then fourth quarter 1.506. Right, so copy the seasonal index. Now you are going to calculate the deseasonalized sales, because if you see the graph of the original sales, there are so many fluctuations. So now your task is you are going to remove the seasonal fluctuations by calculating deseasonalized sales. So what is the formula? So the formula is simple. Deseasonalized value is equal to time series value divided by seasonal index. You don't want to memorize that because it is, you can simply take the deseasonalized sales by using the formula. The normal formula is time series value or the actual value is equal to trend into S, right? So if you want to have the deseasonalized sales, that means the trend, you have to divide Y by S. Divide Y by S. Therefore, divide the sales by seasonal index. Divide the sales, that means divide 7.0 by 0.764. This is the idea. So divide the sales by seasonal index, then do the same for all the other values. Pause the video and do the same to all the other values, and then play the video. So these are the deseasonalized sales. So each sales, we have removed the seasonal component from the actual figures. So if you draw a graph for this, or almost, right, still there are variations, but not compared to the previous one, right? Not compared to the previous one. In the previous one, there were so many fluctuations, but this is because we have very small amount of data. So that variations. Now you can see the difference. So when you are comparing both, original was the blue color, so many fluctuations, but the red color was the deseasonalized sales. Compared to the original, there are no fluctuations. Or you can forecast the trend, little bit increasing, right? Right. So okay, so this is the usage of the second usage, deseasonalized data. So using the same seasonal index, we can seasonalize or we can deseasonalize. So there are two usages. So that is the scope of your entire entire subject. So now I have completed all the 7 learning objectives. So you know how to deseasonalize data. So as a summary, I can quickly recap. So first, we studied about the components of time series. There are 4 components: trend, seasonal, cyclical, irregular. So I told you about the descriptions and how you can define those things. And among those things, trend and seasonal are very important for your syllabus. Then number 2, we studied about different time series models. There are 2 models, multiplicative model and additive model. So you know how to handle those models. Then number 3, I told you about developing a trend equation from the data set and how to do the forecasting. Then that is number 4, how to do forecasting using the trend equation and how to adjust seasonal variations in the trend equation. Then number 5, I told you about smoothing techniques. So we studied 2 smoothing techniques. Number 1, moving average method, and number 2, exponential smoothing method. The purpose of smoothing is to remove the seasonal fluctuations from the data set. Then number 6, I taught you about determining the seasonal index and interpreting it. Then lastly, I explained you about deseasonalizing a data set using seasonal index, right? So that was the coverage. So there's an exercise you at the end. So practice this. This is a bigger one, including 4 years. So the question is, you have to compute the trend line. So two task. First, you have to compute the trend line. Then you have to compute the seasonal index. So what we studied so far, the full scope has been included here. So first, using this data, calculate the trend line, then calculate the seasonal index also for each quarter. So I will show you the answers in the next class. I will give you the answers in the next class. So the next discussion will be about our new subject. So that's all. So if you have any questions or if you want to ask anything, you can talk to me in the next class. Okay, right. Thank you.